Okay, 5.8D, example 4 in partial fractions. So here we go. Numerator has a degree of 2, this has a degree of 3 because of this 2 and this 1. This has the squared, so we're going to have to do that a little bit different. So again, it's nothing new. A over 2x minus 1, b over x minus 2, and we're going to leave that one alone, plus c over x minus 2, the quantity squared. So remember, when this is a 2, we have it once here and once there. All right, so go ahead and find common denominators. I'm going to assume you can do that. I'm just going to write it out here, what we've got then once we find common denominators. And we won't even worry about the denominator then because remember how we don't worry about it. So we've got that, and that equals my 7x squared minus 29x plus 24. Okay, that we took from right there. And, you know, and our denominators are this right there, but I'm not even going to write them. All right, so I'm going to show you something a little bit different. You don't have to do it this way. But let's go ahead and give it a shot. Let's go ahead and expand all of this. We have, if you were to square that, do the FOIL method and do everything there, and then multiply it by the a, you'd get ax squared minus 4ax plus 4a plus 2bx squared minus 5bx plus 2b plus 2cx minus c. I just expanded this. I did the FOIL method, multiplied it by a, and got all this. Multiplied these two using the FOIL method, multiplied it by b, got this here. Took c and distributed. C times 2x, 2cx. C times negative 1 is negative c. And that equals 7x squared minus 29x plus 24. All right. One of the things that I want to bring up to you is the fact that our x squareds, the two of them that we have here, relate to this. Okay? Our 4ax's without an exponent, negative 5bx, and 2cx relate to the variable with just an x, or the term with just an x. So 24 is just going to be 4 times a, because a is just a number, 2b, and the negative c. Okay? So the reason I say that is because I can write this as 7 equals this and this. So it's basically 7x squared. Where we got that? Well, we did it by doing this. Right? Because that is the only way we can get this 7x squared. Alright, so that being the case, we don't even need these x's, do we? So 7 equals a plus, oops, I'm sorry, there's a 2 there, isn't there? Okay, so 7 equals a plus 2b. Alright, let's look at another part of this. Let's look at the 29x, and I use a blue box around that. So negative 29x is found by just the ones with the x's. Negative 4ax minus 5bx plus 2cx. And then because the x's appear in all of these on both sides, they can go away. So negative 29 equals negative 4a minus 5b plus 2c. Okay, now we can erase that. Now the last bit of this, the 24, equals, what do we have left? 4a plus 2b, because there's no x's in these, that's why I'm picking them, equals that. So now I have that information there. 24 equals 4a plus 2b minus c. Alright, so what do I have here? You're like, I have no idea. We have three equations, and we can do the whole system of equations using this. So we can, I'm just going to write this a little bit different. Let's write the top one as a plus 2b equals 7. I'm just flipping them around. 4a minus 5b plus 2c equals negative 29. 4a, whoops, this is negative, plus 2b minus c equals 24. I have a system of equations here, which means I can take these two and add them up, and my a's will cancel and I'll just have b's and c's. Okay? Then I can get rid of another variable and plug back in. So go back in earlier in this chapter in 5.1 or 5.2 if you need to be reminded how to do systems of equations, and you'll find out that your a is 5, your b is 1, and your c is negative 2. And then you can put those numbers there up here in these places, 5, 1, and a negative 2 here over these denominators. So, system of equations to figure this out. So you can do it the other way, or you can do it this way, where we did everything the same. It's just we made a system of equations here in order to solve that. So one more problem and we'll be done. Okay, this is the final method as far as solving these. I don't remember if I went over this or not. I don't think I did. But notice we have a squared there. Okay, and the other one we had squareds out here. But when we have a squared there, it's set up a little bit different. So let me show you how it's set up here. This is going to equal 2x squared minus 1. Okay. Now when you have something like that, where you have an exponent of 2 here and then not an exponent here, what we're going to do is we're going to write that as ax plus b, and then put a c there. Okay? Again, I'm not going to go into the theory on why it works, but if you have an exponent here, you've got to write this as an ax plus b. Okay, so if this is 2x squared minus 1, ax plus b. Okay, so just write that down so that you can recognize it when you actually get here. So I'm going to assume that you found common denominators and your numerators is all you're concerned about. And we get ax plus b times x minus 3 plus c times 2x squared minus 1. Okay, and that equals, when we do the FOIL method, ax squared minus 3ax plus bx minus 3b, so all four terms there when you did the FOIL method. Distribute that c. And then at that point, we start pulling some things out. So we're going to pull out an x squared from there and here. So we have that times a plus 2c. So that goes away and that goes away. And then we've got our negative 3a plus b times x. Okay, so we pulled out an x out of this and this, so those go away. And then we've got plus a negative 3b minus c. You can't pull anything out of there. Okay? Then we go back, and we've got 11x squared minus 8x minus 7. Now we start looking at comparing this 11x squared to what we have over here. So the only thing that's squared is this. So we have 11x squared equals, and we can cancel those. So 11 equals a plus 2c. So I'm going to put that up there. Okay. And then I look at my negative 8x. Negative 8x equals negative 3ax plus bx from right here. And again, we can get rid of our x's, and up here in the upper right, negative 8 equals negative 3a plus b. And then we're going to look at the negative 7. Negative 7 equals whatever we have left. Negative 3b minus c. So negative 7 equals negative 3b plus c. Okay, so our three equations here in our system are a plus 2c equals 11, negative 3a plus b equals negative 8, and negative 3b plus c equals negative 7. So there are my three equations taken from the upper right hand and flipped around. And now I just use my system of equations to find a, b, and c. And I find out that my a is 3, my b is 1, and my c is 4. So I have these over 2x squared minus 1. And remember my a, look at my a and b. ax plus b. So I'm going to have to write this as 3x plus b1. Okay, so 3x plus 1 plus 4 over, okay, because 4 is my c, so it goes there, 1 is my b, and 3 is my a. So it looks like this. Now if I were to, oops, plus sign, add those together, I would get that back. Alright, so sorry for the pain, but that is 5.8.